In opener 20, we're going to start with a problem that might look very familiar to you. It should, because if you look at the problem before, it looks similar. But the problem before was x squared plus 18x plus 77 equals 0. And that's not this problem, right? We have x cubed plus 18x squared plus 77x equals 0. And the reason I put this problem on there is for you to start thinking about, well, I have to think about factoring out as well as factoring into two binomials. Okay, so what do each of these have in common, if anything? They might not always have something in common, but you always have to look for it. It makes your life simpler. Hopefully you recognize they all have an x as a factor. So I'm going to factor out x, and I get x squared plus 18x, sorry, not squared, 18x plus 77 equals 0. If you look at the problem above, I've already factored this, right? I found it was x plus 7, x plus 11. So this is x plus 7, x plus 11. And I keep my x out in front because that's still a factor. And if I were to remultiply all of this, I would end up with the original. So now I can apply zero product property because I have three things now being multiplied together to equal 0. So that it still applies, right? No matter how many things you have multiplied equal to 0, one of them has to be 0. So then I'll set this equal to 0 to get x equals 0. So 0 is one of the possibilities, or x plus 7 equals 0, which gives me x equals negative 7. Or I set this other one equal to 0, x equals negative 11. So those are your three possible answers. Now some of you might be starting to draw the pattern here and see, oh, well, it's always the opposite of what's the number inside the parentheses. And that's true as long as you're dealing with a single x squared. Like it's not 3x squared or 10x squared or negative 2x squared. Once that happens, the pattern starts to break down in terms of recognizing the pattern, but you'll always be able to set it equal to 0 and solve for it. And we'll start to get to problems like that a little later on in a few more openers. Okay, looking at the next one again, I don't know how to factor this, so I'm hoping I can factor 3 out. Again, if the numbers add up to a number divisible by 3, then I know the whole thing is divisible by 3. So 9 is divisible by 3 and 6 is, so I know that 54 and 231 are divisible by 3. So let's factor out everything. Let's factor out a 3 and let's factor out an x. So 3x. This leaves me x squared plus 3 goes into 54, 18 times, and I've left with 1x because I pulled only 1x out, plus 3 goes into 231, 77 times. What do you know? The same exact problem, same exact trinomial as that one. So again, don't have to spend a lot of effort. I've already done this one. X plus 7, x plus 11 equals 0. I have a 3x on the outside. And the reason I gave you this problem, right, this original problem is just 3 times as big as the other one, is you could think of it like this. There's a couple ways to think of it. The first way to think of it is, well, I could just set 3x equal to 0. What value of x makes 3x equal to 0? Divide both sides by 3. X is still 0. It's still the same result as above. Another way to think of this is I could have just divided both sides. Let me do that over here in red. 3x x squared plus 18x plus 77 equals 0. I could have divided both sides by 3. And I would have gotten x times x squared plus 18x plus 77 equals 0, which is exactly, literally exactly the same problem as I had above, right here. Scroll up. Now you can see this is exactly the same problem. So that 3 really, when equal to 0, does not play a factor at all, but you can always play it out to find out. So again, I get x equals 0, or negative 7, or negative 11. So a couple big ideas here. Factoring out, looking for factoring out is important. And when you have constants that are the same across, when you have that all equal to 0, you can just divide everything by that constant, and 0 divided by that constant is still 0. So you can reduce the complexity of your problem, thus helping you get to the right solution more efficiently and more accurately and more consistently.